Friends, we are having a session on pneumatic signals, and whenever we say pneumatic, it means we are making use of gas pressure for some industrial need. So the application is generally to create some kind of force by providing a gas pressure to a piston or a diaphragm, and in general this pneumatic signal is mostly carried out by some kind of moisture free, that is dry air. It's normally lubricated, it's filtered, not containing any dust particles, and the signal as such, the pressure signal, is of the range of 3 to 15 psi. This is the standard range of 3 to 15 psi. In the previous sessions we had seen that we had air to open valves, air to close valves. So they all accepted 3 to 15 psi as their standard input. So if in case it is air to open valve, at 3 psi the valve will be 0% open. At 15 psi the valve will be 100% open. But again we had seen that in a closed loop, in a feedback control loop, the output of controller, it goes to the final control element, and the final control element is a valve, and the valve requires 3 to 15 psi. I must clarify, when I say final control element is valve, it is not necessarily always a valve, but most of the times it is a valve to control some kind of flow. So now the requirement of final control element is that it requires 3 to 15 psi signal, as you can see from here. But the electronic controller gives the output in terms of 4 milliampere to 20 milliampere. So we need to have something which converts 4 milliampere to 3 psi and 20 milliampere to 15 psi. So those kind of converters are called current to pressure converters. They are called I2P converters. They are also sometimes called I2P converters, and so on and so forth. So they are converting the various types of electrical or electronic signals to pneumatic signals, and further how these signals are amplified, how these signals are transmitted, how these signals are converted, and so on and so forth, we shall be dealing with in this session on the pneumatic signals and the pneumatic devices which are working on these pneumatic signals. So in case you are using SI units, so we are to convert 3 to 15 psi into its equivalent 2200 kilopascal. Now this psi, those who do not know, it stands for pound per square inch. This is unit of pressure. Pound is force because it's in force in terms of weight, pound weight. You have to multiply by G. G in FPS system is 32 feet per second square per square inch. Many times some of the engineers, they make use of term G over here. G stands for gauge pressure. It's a gauge pressure, that is the pressure above atmospheric pressure. Now, as I said, that we'll be going in for three different types of signal conversion, and we'll be discussing all these three signals one by one. With a pneumatic amplifier or a booster, and what you see on the diagram over here is a pneumatic amplifier or booster which converts either a signal pressure to higher pressure, or even at the same pressure but with a greater gas volumes. What you see over here is a type which is reverse acting and bleeding. So there are three things which you have learned: that there is something called volume amplification. So far we knew only about the pressure amplification. What do you mean by volume amplification? Second, what do you mean by reverse acting? And third, what do you mean by bleeding type? All these questions which might have arisen in your mind will be answered in this particular slide. So let's focus on what's happening over here. So friends, this is the plug, a specially shaped plug. It's a double-headed plug. This upper head fits in the upper seat, and the lower head, it fits in the lower seat. And right now, neither of the seats is fully blocked by any of the two plugs, and this plug is in an intermediate situation or intermediate position, and there is some signal pressure acting on it. Let us suppose what happens if this signal pressure increases. This is the first thing which you want to know. What is going to happen in case this signal pressure increases? If the signal pressure increases, signal pressure may be in terms of 3 to 15 psi. In that case, what we see over here is that this pressure is going to push this diaphragm in an upward direction, and as it moves up, this plug, it moves up, and this plug also moves up, and it closes the seat over here. As it closes the seat over here, the air supply coming from that gets restricted or lower, and this particular seat, as it's moving up, it becomes leaking over here, increases. So whatsoever is the output pressure which was earlier maintained by this air supply, its supply connection is cut off, and it rather gets connected to the leak. So the output pressure reduces on the account of this plug moving up. Yes, my dear friends, you heard it right. The output pressure decreases on account of this leak increasing, and this air supply, it is getting obstructed. So remember, it was that when signal pressure was going up, the output pressure is going down. Conversely, when the signal pressure goes down, this diaphragm will come down, and this diaphragm will come down, so this plug will come down. When this plug will come down, and this plug will come down also, by this plug going down, this particular opening will increase, and this particular opening will decrease. Decreasing of this opening means that the leak over here will reduce, and the opening of this hole over here, this gate or this channel over here, this is increasing. It means that the air supply over here will increase, and thereby this increased air supply and reduced leak will result in higher output pressure. This will result in higher output pressure. So my dear friends, once again it is seen that if as this signal pressure goes down, the output pressure increases. That is why this device is reverse acting. Reverse acting means the pressure over here is increasing, the output is decreasing. When the input is decreasing, the output is increasing. It is like inverting amplifier. Inverting amplifier has a phase difference of 180 degree. So is the case with this kind of amplifier, which is also sometimes known as booster, which is also sometimes known as relay. So you can call it as a pneumatic amplifier, you can call it as pneumatic booster, or you can even call it as a pneumatic relay. So friends, as we have seen over here in this case, because of the fact that the phase change is there, we can have this air supply which is much higher than the signal. The signal may be varying anything, like for example, it can be from 1 to 5 psi. It can be increased to 3 to 15 psi. It means that the pressure is multiplied 3 times. That is also possible. And sometimes what we need is that the pressure over here is 3 to 15 psi, and the pressure over here is again 15 to 3 psi, because it's a reverse acting thing. There is no change in pressure, but here the flow rate is very low, because this pipe may be very small. This pipe may be very small, or the signal is coming from some orifice, or the signal may be coming from some restriction where the airflow is very small. So because of this restriction or orifice, the small air flow rate over here, is able to fill this small volume. This is a small volume over here, but the output of this may be coming from a very large pipe size over here, large pipe diameter over here. So here the flow rate is higher, and the advantage of higher flow rate is that the dome of the pneumatic valve which is there, which is going to press the huge diaphragm of the pneumatic valve, which can be as big as your room, for example. So all those walls can go up and down. If they are connected directly to the small pipes, they will take several minutes or maybe half an hour for the wall to move up or to move down. We need to increase the flow rate, and that is done by putting in this kind of relay or this kind of booster, which doesn't change the pressure but changes the pressure remaining same. It changes the flow rate, so in that case, those kind of things, we say they have greater gas volume. They're a volume amplifier, just the way you have current amplifier. These are called volume amplifiers. Because of the fact that you have leaking taking place over here, this kind of valve is also called a bleeding type of relay. So now you know what is the meaning of reverse acting. Now you know what is the meaning of a bleeding type. And now you know what's the meaning of volume amplifier with greater gas volume. This is all about the pneumatic amplifiers or boosters or relays. We move on to the next device, which is the heart of pneumatic system as such. We will be talking mostly about the nozzle flapper unit. So what's a nozzle flapper unit? Let us see. So friends, as you can see, you have a nozzle flapper system where first of all you have a nozzle over here, and then you have a flapper over here, and in between the flapper and the nozzle is a small gap. So this flapper, it can move down or it can move up. When the flapper moves down, in that case the gap reduces, and as this gap reduces, what is going to happen? The leak over here will actually decrease. And when the flapper moves up, this gap increases, and as the gap increases, the leak over here also increases. Now what is getting leaked? There is a supply pressure, and this supply pressure is normally 20 psi. And this supply pressure moves over a restriction, and as it moves over restriction, depending upon the flow rate, there is going to be pressure drop. This is just like electrical resistance, where as the current increases, the voltage drops. Similarly, here also it's a restriction, so as the flow rate increases, the pressure drops. And the flow rate depends upon the gap. If the nozzle flapper moves up, the gap increases, the flow rate increases, the pressure over here drop increases means the pressure becomes lesser. More drop, lesser pressure. And this lesser pressure is going to become the signal pressure over here. So as this flapper is moving up and up and up and up, the gap is increasing more and more and more and more. The more flow rate over here is going to make the pressure drop higher. Drop is higher means pressure over is lower, so the pressure becomes lower and lower. Conversely, when the flapper moves down, the gap reduces, the flow rate decreases, and the drop decreases. And the drop is decreasing means that the pressure over here is now becoming more. There is lesser drop, more pressure. So this pressure over here is also more. So as this flap moves up, the pressure is less. As the flap moves down, this pressure, the signal pressure, is also higher. So this gap over here and the pressure signal over here, they are inversely related. I'm not saying that inversely proportional, but they are inversely related. So as the gap goes down, the pressure goes up, and this pressure, my dear friends, is mostly in the range of 3 to 15 psi. That is what we see over here. This is the functioning of nozzle flapper unit, and we shall be giving you a plot between the gap and the pressure over here, which is normally exploited in the linear region. That's what we are going to see in the next slide. So what is this? This is the gap distance and this is the signal pressure, and it follows this sigmoidal kind of thing again. But you see that somewhere between this point and this point, this relationship is almost linear. It's quite linear. It's very much linear. It's like a straight line. And this we take it as 3 psi to 15 psi. Even if it is not 3 to 15 psi, it is given to some kind of amplifier, some kind of pneumatic amplifier, some kind of pneumatic booster, or some kind of pneumatic relay, which converts it into 3 to 15 psi. And this inverse relationship is also corrected sometimes, so that again, because the amplifier is a again reverse acting, so the reverse of the gap is also taken care of with this amplifier. So this combination as such of a nozzle flapper unit with the amplifier becomes the overall detection system, where the slight movement in the flapper, there is a slight movement in the flapper, that movement in the flapper or the force acting on the flapper becomes the input, and the movement of the flapper is converted into the output. The output is in terms of pressure, that is 3 to 15 psi. Now we come to the current to pressure converter. So what's happening in current to pressure converter? Again, we see heart of this is again a nozzle flapper unit. Just like before, you have a supply pressure which is 20 psi. The final resulting output is 3 to 15 psi. You have a restriction just like as before. The same flapper nozzle gap arrangement is there, but this time you have an additional spring acting on this particular flapper, and there is a solenoid, there is an electromagnet which is carrying the 4 to 20 milliampere. So 4 to 20 milliampere current is going in this, and this, depending upon the strength of this milliampere, the strength of this magnetic field, and therefore the force with which it is going to push this down, or you can say pull this down. Now let us see what happens. Very systematically, let us see what happens. As the current over here increases, the current over here is increases, it means that the current flowing in this coil is also increasing. It's pulling this flapper down, and it's pulling this flapper down. This spring is there to resist. It's going to say no, 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 don't go down, don't go down. But then ultimately this is a linear spring, so force is equal to k into x. So some amount of x, some amount of displacement will take place, and that x is going to reduce the gap, and the gap reduces, the flow rate decreases, the pressure drop decreases, and the pressure drop decreases means the pressure signal increases. So as the current over here increases, the signal over here increases. As we see, it is calibrated by making use of this spring in such a manner that when you have 4 milliampere over here, you have 3 psi over here. When you have 20 milliampere over here, you have 15 psi over here. So effectively the input is 4 to 20 milliampere and the output is 3 to 15 psi. This is what we exactly wanted for I2P converter or current to pressure converter, that corresponding to 4 milliampere you should have how much? 3 psi, and corresponding to 20 milliampere you should have 15 psi. So this is effectively converting a 4 to 20 milliampere coming from any controller, electronic controller, to 3 to 15 psi pressure signal, which will go to the final control valve, final control element as a pneumatic valve, for example, to control the flow of the process. So this is how the current to pressure converter it works. This is the schematic of it. We will also see how it actually looks, practically how it actually looks in the next slide. So what we see, as I said earlier, that the 4 to 20 milliampere, it's coming in the form of an input from the electronic controller, and then you have this current to pressure converter. It is many times I said also called I2P converter. So what you see, you give electronic signal to it in the form of current from 4 to 20 milliampere. You give instrument air supply. It is normally filtered and regulated mostly to 20 psi. It is filtered of the moisture and of the dust or dirt particles, and slightly lubricated also. And all these this filtered air, clean air, it goes to the input of I2P converter, and we get the output from this kind of I2P converter, which is in the form of 3 to 15 psi. As we can say, this is for the 100% time. If it's a 20 milliampere over here, you will have 15 psi over here. This is a master pressure gauge which is going to measure by this meter. You can measure that it's actually 15 or not. If it is not, then we can make some adjustments which are given over here to calibrate it to 15. This is how I2P converter looks like from outside, but what is its inside structure, that's also we're going to see in the next slide. My dear friends, as I said, this is the flapper. If you remember the flapper, and then you have a nozzle. Here you somewhere you have a nozzle, and then this flapper and nozzle system are moving up and down. It's a sensor, and then as you can see from here, there are some resistive bellows also somewhere over here. Some spring is there, and so on and so forth. So all those things which I discussed, they are, that's how they look from inside. For this is the inside view of current to pressure converter, which is very commonly used in most of the industrial applications. So this was about the pneumatic signals and the pneumatic conversions and the devices which we are used, which are normally used for the handling of these pneumatic signals. In case you have any queries, you want to share something with me, you want to ask something from me, you can always contact me through various means, like you have LMS or WhatsApp, or you can contact me through phones, Zoom sessions, etc. etc. I thank you for being with me once again, and I wish you a very safe stay and enjoy learning. Bye bye.